Scott, can you hear me?
I can, and thanks
Excellent.
everyone for thanks Julian, thanks everyone for attending today. If you haven't worked with Biml before, maybe you've just heard about it. We're going to be starting from scratch, assuming that you know nothing about Biml. But even for those who have played with it before, hopefully you'll be able to take away a few nuggets and tips for being more productive with it. So essentially, as Julie mentioned, we're going to be starting from scratch and creating a full-blown staging environment using Biml and by using the metadata that's provided by a source system in order to drive the creation of our tables and our load packages. So I'm just going to spend the time on 2 slides before jumping in, and the rest of it's going to be demo-driven throughout the rest of the hour. So one of the things that we do want to do before diving into the technical details of Biml is just step back very briefly and discuss what it really is all about. It's not just about having some cool technology that can do some neat things automatically for you. It's really about accomplishing goals. And what Biml allows you to do is entirely on top of the Microsoft BI and data warehousing stack to build those projects out more quickly, more consistently, and also very reliably, perhaps even more so than you ever thought possible. And this is a really important thing given how much of our lives we spend in these technology stacks. To make it fun again, I don't think very many of us got into business intelligence because we really liked dragging and dropping onto a design surface and recreating over and over again manually the plumbing required to build an enterprise solution. We got into it generally because we loved the feeling of creating new insight from a few bits of data. And what Biml lets you do is get out of the plumbing game and get back into creating new and interesting insights that that otherwise wouldn't be possible. How do we do that? Essentially, Biml is business intelligence markup language is an XML dialect, and we're going to see a lot of this in the following 15 minutes or so, that models most of the Microsoft SQL Server platform. We have a free version of this, 100% free in BIDS Helper, which is an add-in. We're going to go look at the page for that in a second so you know exactly where to go to install it. BIDS Helper, by the way, has a whole bunch of additional features beyond Biml that are really compelling as well. What Biml does in the BIDS Helper subset is it allows you to model out your relational database stuff, and it allows you to model out your SSIS packages. And it has tags that have essentially one-to-one correspondence with everything that you're going to find, if you're working through your visual design surface or the SSIS API or some of the interfaces that are available for the relational database. But because we've used this tag approach with this human-readable and writable XML, it means we have the opportunity now not only to auto-generate that XML out of a variety of tools that understand XML already, but also to take an ASP.NET type approach and inject little code nuggets of C# or VB interspersed with our Biml XML tags in order to read metadata or other data sources to automatically generate that Biml so that we don't even have to do the Biml by hand anymore. All of that gets plugged into the Biml engine. The scripts that you're developing for the project that you happen to be working on right now, plus maybe shared scripts that you've gotten from the community or that you've developed yourself and use across multiple projects. What we'll be developing today would certainly be a candidate for being a shared script for lots of different projects going forward. And once they go into the Biml engine, and this is the really important part, all that gets generated are standard Microsoft SQL Server assets. There's nothing to install on the server. In fact, if you're using this in a customer engagement or if you've got an IT manager who is a stickler about not using third-party products, you're not actually using third-party products after you hit build. What it does is spit out things that are indistinguishable from what you would have built by hand in BIDS or SSDT. So you've got your database and schema definitions in T-SQL, which you can access, and of course you're generating DTSX packages. So with that overview, let's go ahead and jump in and see how the mechanics of this work. If you haven't installed BIDS Helper already, that's the first step. The first thing you have to do is go to bidshelper.codeplex.com or codeplex.com/bidshelper. They both work. And you'll be brought to the page for this free project that's on the Microsoft CodePlex site. And as I mentioned before, there are a ton of features that are available in BIDS Helper. And here's the full list, stuff that you can do: analysis services and tabular and integration services, reporting services, general. And Biml package generator, this is the part we're talking about today. It's a pretty big single feature, but it's just a single feature. So even if at the end of this talk you say, you know what, I'm not interested in BIML, please do yourself a favor and go ahead and install and start using Bits Helper. It will really make your life easier as a BI professional. So all you have to do is go to Downloads and select the installer that you want to use. If you're using multiple different versions of SQL Server, just go ahead and pick all of the versions that you normally work with and install for each of them. There's separate installers for each version. So here we have the one for SQL Server 2012, here's the one for 2008, and here's the one for 2005. The 2008 is good for both R2 and not R2. A quick note here, there's both an XE-based installer that does require that you have administrative permissions on your box in order to get the permissions escalation on the XE. If, however, you're in an environment where you actually are not allowed to install software on your machine, no problem. There's also an Xcopy deployment option, which is offered here for these zip files. So regardless of what type of environment you're working in, if you've got BIDS, you should be able to use Bits Helper. Okay, so from this point forward, I'm going to assume that you've got Bits Helper installed, and we're going to jump over into Visual Studio 2012 and start with a brand new project. So here we go, and this is, I'm sorry, Visual Studio 2010, this is SSDT targeting SQL Server 2012. I'm going to create a new integration services project, and I'm going to call this automated staging. And once my project is created, one of the things I'm going to notice, and I don't need this package because we're going to create a whole bunch of packages automatically. Basically, the only difference I'll notice for BIML is that if I right-click here on my project, I've got one new option in my context menu here, which is Add New BIML File. So if I go ahead and click on that option, it puts a new BIML file for me underneath Miscellaneous. Now, this is a common way to get confused. Unfortunately, the SSIS project model doesn't expose a hook to add a context menu to Miscellaneous. So even though the BIML files go under Miscellaneous, the only place you can't click to add one is Miscellaneous, unfortunately. So just go ahead and click anywhere else. Project level is a good way to remember it, and click Add New BIML File. And what that produces for you is an empty BIML file that's ready to go. Now you'll notice this opens up in the standard Visual Studio XML editor. And in fact, if you use the XE installer, when I do an open bracket here, it actually loads up the XML schema for me, so I get IntelliSense through the XML editor for all of the tags that are available in BIML. Now, if you did the Xcopy deployment, you'll actually have to copy the XSD into your schemas directory yourself. But for most of you, this should just light up as soon as you've installed Bits Helper. So let's take a quick tour of the language here. So everything starts at this root node, which is called BIML, that lives in this namespace. This is actually an arbitrary URL. It's just something to make sure that we have identified our schema uniquely as compared to everybody else in the world. So if I do an open bracket here, we'll see some of the things that I can do. We can define connections. We can define databases. We can define file formats. And notice that file formats in BIML are a root level object that can be shared across many different packages. We can define package projects. We can define packages. We can define schemas. These are database schemas. Script projects, just like file formats, script projects are entirely reusable. So you can define a script project in one file and reuse it across all of your packages where you want to leverage it. And if you need to edit that script project, you edit it in just one location and do a rebuild, and you don't have to worry about maintaining it across a variety of different script tasks and script components. And we can also define servers, and we can define tables. You may have noticed as I was looking at this IntelliSense here that I didn't actually mention a couple of the items in there. That's because we actually published the full schema because there's one XSD for all of BIML. The things I didn't mention are in analysis services, which aren't supported in the free version. The free version is SSIS and the relational modeling only. So we're going to create a staging environment, and in order to create a staging environment, we need some connections. We need a source system that we're going to pull from, and we need a target system that we're going to be staging our data into. So I'm going to go ahead and do an open bracket, and I'm going to define myself a connection. And a good way to start learning BIML is to work with the IntelliSense, or maybe more accurately, let the IntelliSense work for you. So if I want to know what's available under a connection, I have basically two options. I can hit spacebar here. Well, okay, there are no attributes, because if there were attributes, hitting spacebar would have popped up a list of available attributes. So maybe there are some children under there. Okay, there are some children. I can define one of a variety of different types of connections here. I can do ADO.NET connections, cache connections, that's for lookup caches, for example. I can even define custom SSIS connections if I like. I can do ODBC. In our case, we're going to go ahead and do an OLEDB connection. So I define my OLEDB connection, and I want to go ahead and name my OLEDB connection source. And I want to provide a connection string. And I'm going to do that there. And the connection string, for me, this is probably the hardest part. I always forget this connection string syntax. So it's going to be SQL and CLI 11, and my server, for the purposes of this demo, is going to be localhost, and my initial catalog is going to be data patterns, and that's just the Scratch database I have. One of the things that we're going to see as we go further in the demonstration here is that we're actually going to change this string later on, and we're going to point it to VentureWorks after we've done our initial development, and you'll see that the scripts that we build once are reusable as many times as we like. So that's it. There's my connection string. So I've got a connection, an OLEDB connection named source, and it's got the following connection string. Now the next thing I need to do is define a target. So I'm just going to copy and paste and make some changes. So here I've got target, and I want to have this one go to, let's call my database data pattern stage, and that's it. There are my connections. Now there's one more thing that you have to do. We're going to be defining tables for our target schema, but before we define tables, we need to actually point out which database and schema those tables are going to go into. So here I have the ability to say I want to create some databases, and I'm going to do a database here. And for those of you who are thinking this is a little mundane, I agree with you. You are right, and unfortunately this is just what we have to do in order to set up our environment. And once we're set up in this environment, we'll be able to start writing some script in just a couple of minutes, and that'll be really fun. So one of the things you're going to notice here is that a database has to live on a connection. So BIML has this concept of internal interconnected referenceability. So I can now, instead of having to redefine the connection here, I can just reference one of these connections that I've already created. Now specifically, I want my staging database to be on my target connection. So my connection name is going to be target, and that creates the reference for me, and that's it. My database is now configured. I don't need at this point to do file groups or anything like that. I could define that if I wanted to, but that's something I'll let my ops guy manage. And I'm going to go ahead and have a schema, and this is just really straightforward. I'm going to name my schema STG, and where does it live? Database name, data pattern staging. Now, one of the things I do want to point out here is that the error mechanisms will also help you out a bit with what's going on. You'll notice here that there are no error squigglies because I've actually written the code correctly. But database name is a required field. So if I were to remove that, you'll notice that we actually have a little blue squiggly here that tells us it's missing the required attribute database name. So as you're writing, if you see any of these blue squiggles, definitely hover over or go to your error list and pay attention to what they're saying because they're giving you essential information. So here I'll put back database name, and my squiggly goes away. So I'm going to go ahead and save this. And this is really all I need to configure my environment, both my source and my target. So I'm going to name it appropriately. I'm going to change it from BIML script to just calling it environment. Now that I've got my environment settings, I want to go ahead and actually create some tables. So to do that, I'm going to go ahead and add in another file. And this one is going to be called create table metadata. You'll see why we call it create table metadata in just a second. Because we're not actually creating the table generate scripts here. We're creating an in-memory representation of what those tables are going to be, and then we're going to use that in a few other different places. So I'm going to go ahead and open up create table metadata, and we see that we've got another BIML file here. And I'm going to now say I want to add in some tables. So before I get into the whole scripting part and show you how we're going to write some code to automatically figure out what these tables ought to be based on my source connection, I'm going to show you a little bit of what's inside the table. And this is kind of a good way when you're thinking about first learning BIML. Don't start writing code nuggets, which you'll see in just a second. Start by kind of scaffolding out your solution the way you want it to look, and then replace your statically defined temporary values with those code nuggets once you're ready. So I want to create a table, and I'm going to have a naming convention in my database where I just call this thing staging underscore, and then I want to use whatever my schema name is, and then I want to have whatever my table name is. And this is nice because now I can put everything in the SDG schema and not have to worry about any conflicts. In point of fact, I could even stage multiple data sources into this one database by doing it this way. So I'm going to name my table that, and I want to go ahead and point this thing at a schema. And there are a variety of different ways to reference this, but fundamentally I'm referencing the schema that I created there in environment. Now, the name of this schema is not just SDG, it's actually data pattern staging.sdg. You have to give it the fully qualified name here. So I'm going to say data pattern staging.sdg. So it's saying my table is going to live in that staging schema. And then I want to have some columns. The table is interesting, is going to have some columns in it. And in here I have to do some column definitions. Now I could manually go through and say I want to have a column here. And this is kind of an interesting point. We're going to automate the generation of the columns in just a second. But if for logging purposes, for example, you wanted to have some standard columns that were part of your framework that were injected into every single staging table so that maybe you could track the lineage or the source of individual rows if you were staging multiple data sources into a single table, you could go ahead and put your standard columns up here, and say things like name, log metadata, whatever it happens to be, and then give it the data type that you want it to have. You can not do that. It's totally up to you. But then in addition to those standard columns, we're going to have some script that auto-generates the columns that actually are the meat and potatoes of the data that's being stored. So that's what we have now. This is a good scaffold, so let's go ahead and start adding some code to it. The first thing that I'm going to want to do is get access to my source connection. So the way I'm going to do that is I'm going to put in this little BimlScript code nugget here. So anytime you do bracket pound, that says I'm about to write some code in here. And this code can be C# or VB. My personal preference is for C#, so that's what I'm going to use here in the demo. And most of the samples on mine are C# too. If you really don't have a strong preference for VB, using C# is probably the better choice, at least at this point. And these code blocks allow you to do things like define variables that you're going to use or add control structures. I'm going to go ahead and define a variable called source connection. So var source connection. And this is just C# language. Var says figure out the data type for me. I could actually put the data type here, but var says you can figure it out, compiler, handle it for me. That's not something I want to trouble myself with. And then in here under my source connection, I'm going to take root node dot connections. And actually, I'm going to go ahead and grab .db connections because I'm only interested in the database connections. Then I'm going to say I really want the source. And the root node corresponds just to the project. So this is one of the really neat things about Biml. You can actually use assets that you've defined earlier in scripts that you write later. So here I'm saying go into my root project, go into all the connections, or in this case filter them out to the DB connections. We have documentation online that we'll point you to that has all the things that are available on root node and all the other objects. Give me the database connections, and specifically I want to pick out the one named source. And now once you've got that source connection, you can start to do some fun things with it. You can say source dot, and we have a bunch of helper methods that are also documented. And one of them, which is extremely useful, especially for these sorts of staging applications, is called import DB. And by the way, this is probably the most complicated bit of code that we're going to write, this one line right here. Import DB takes some arguments. The first one is, do you want to filter out any schemas? I'm going to say nope. I could put a little, basically a like string in there with like syntax where I could say only give me things from schema that contain stage, for example. But I'm going to say just give me everything. And here's my table filter. I'm going to say give me all the tables. But I am going to specify some things that I don't want included. So import options. And one of the things you're going to notice here is that the editor for XML is built into Visual Studio. It doesn't actually understand C#. It doesn't understand these code nuggets. So the IntelliSense gets kind of confused at this point. And that's just something that we have to live with if we're using this editor. There are other editors that can do a better job of this, but this is the one that's built directly into the free offering here. So I'm going to do exclude foreign key because I don't want any foreign keys. I'm just staging. I'm also going to do, and this is just a pipe saying or, combine those options together. Right, so I'm also going to do an import options dot exclude column default. And I'm going to do another bitwise over here and say I want to do import options dot exclude views. Now this one line of code that's pretty complicated if you don't already know what the object model looks like. This isn't the sort of thing that I would expect you to just to sit down and start typing. Generally speaking, you'll go to brimblescript.com or some other places online that I'll point you to and grab a sample that somebody else has already written that gets you half of the way or maybe even further along the way of what you need to do. And then you'll just go ahead and use that. So I'm going to do import result, and I'm going to assign this here to a variable. So my import result is going to be equal to this source.importdb. And now in import result, what this did is it's going to go and talk to this database, and it's going to say, give me a listing of all the tables that are in this database, regardless of the schema, but leave out the views and leave out some of the stuff that I don't need. And it's going to pop it into this object called import result. Now we get to use that. So further down here, I can put in another code block and say, you know what, I just want to reference that import result that I have up there. So I want to have a whole bunch of tables, one for each thing that I'm seeing in the source, one for each table that I'm seeing in the source. So I use my C# for each iterator block, and I just say for each var table in import result dot tables. I am going to create a table. So this is the beginning of my for loop. I need to have an end to this for loop. So the great thing is you can actually have these control structures span your blocks. So I actually want to have my table created, and my for loop begins up here and it ends down here. So every time the for loop iterates, it's going to spit out this demo code that's sitting in here inside the block. Now the only thing that we have to do in order to round this out is to take this table object that I have for each iteration and use its values in order to customize the table to make it look the way I want to. So the first thing I want to do is take the schema name thing and I want to replace it with the actual schema name. We have a very robust object model here. I'm going to do table.schema.name. And you may have just caught me doing something without explaining it. Wait a second, what is this that I'm looking at? What is this bracket pound equals? You were doing bracket pound before. Bracket pound equals is a different type of code nugget. What this one does is it says whatever you have inside this code nugget, spit it out as a string. Notice this isn't spitting anything out as a string. It's defining variables or it's creating control structures, you know, conditionals, loops, etc. This is saying don't evaluate anything other than to get the string out of it and then spit the string out. So I do that to get my schema name, and I also want to do that to get my table name. Perfect. I have my schema name that this is going into is already done, and then the only thing that I need to do now, we're going to come back to customizing these columns a bit in just a moment. But for now, this is actually a really cool feature. Everything that got pulled in as columns from my source database, if I ever want to take something that I have an object handle to, right? I've got this table object that I've already accessed its schema and its schema name, and I've already accessed its name. I can take anything in the entire object model, and I can just call .getViml on it. And if I call getViml, what that spits out is the equivalent Viml code for whatever I just called that on. And I'm not limited just to calling it on a table. I can also call it on a collection. So I'm going to, my table columns, remember, just like we have columns here, we have an equivalent property for that. I can just go table.columns.getViml, and it spits out the Viml for all my columns. And that's it. Right now, I've got a table. And if I were to build this script, I'll have the in-memory model for my table, and then I could even, as we're going to do in just a second, spit out the DDL for this table so that we can build it. But I want to do one more thing, because I'm looking ahead to building packages off of this. What I need to do next is actually create an annotation. An annotation is a very powerful Viml feature. What it allows you to do is take any object in the entire object model, anything in Viml, and you can put an annotation on it. You can even annotate annotations if you want to. And what this allows me to do is just put some supplemental metadata that I'm usually going to go ahead and use later. And in order to identify what the purpose of this particular bit of metadata is, I can use a tag. So I'm going to tag this as being the source schema qualified name. And it's probably, a few of you probably recognize the purpose of this. I just renamed this table. It has a different name in my target than it does in the source system. But I need to know both the new name and the original name if I'm going to build a staging package for this later. So I go ahead and have tag source schema qualified name. And then I need to actually put what the original schema qualified name was. And for that, I just have another one in here, which is table.schema qualified name. And this is another one of those things that the BIML API builds in for your convenience, so you don't have to construct it yourself by doing schema.name.table.name and putting brackets or quotes around it or whatever. It figures out the provider and gives you the right schema qualified name. So with this, we've actually got all of the table metadata that we need to create. And now we get to have a lot of fun. We get to actually write our packages that are going to get auto-generated using this as a source. There is one more thing that I have to do before I move on, though. And this is one of those things that you also wouldn't be expected to know, and it's better to, as you're first getting started, to find this in a sample. This import DB is not something that's part of the standard library. It's part of one of our extensions. So in order to use that, you have to use this thing at the top called a directive and put an import in here. The import is basically like using in C# or imports in DB. It brings in a namespace for me to use. So I'm going to go ahead and import a namespace. And my namespace is just going to be Verogens.headrun.core lower.schema management. And this is just where that helper method just happens to live. And that's all there is to it. So now that we've got this, we've got our reusable metadata creation script. The next thing I'm going to do is add one more BIML file. And now here's where we actually get to create some packages. So what I'm going to do is call this one deploy target tables, because that's what the package is actually going to do. Deploy target tables. And once I have deploy target tables, now I can jump in here, it's the deploy target tables, and I can create my collection of packages. And we're going to see these scripts come together really fast now. In the next 15 minutes, we're going to have a working project that does everything that we were talking about. So I'm going to have some packages, and I'm going to scaffold it out just like I did the tables, and I'm going to use the IntelliSense to help me. I want to have a package, and I want the package to be named. In this case, some people say I want to have one package per table and then call those packages from a master. In our case, I'm just going to have one package that deploys all of them. So I'm going to call this one master table deploy. And there's this thing called constraint mode. You don't have to worry too much about what this does. We essentially have, and this makes scripting easier. We're actually going to, we may see this a little later. Parallel matches exactly what BIDS does, where you have to create all your precedence constraints between the child tasks manually. Linear says, hey, you know what? It turns out that I want these things to run sequentially, so instead of having to manually create those precedence constraints, especially in scenarios where I've got code automation that's spitting out a bunch of tasks, just go ahead and create a default precedence constraint for me and put the things in the order that they appear in the file. In our case, we actually want our tables creation scripts to run in parallel, so I'm going to use constraint mode parallel. And then packages can contain tasks, right? These are control flow tasks. This is going to be the control flow window in SSIS. And then the task that I'm going to want to run here, well, I want to run some SQL to create those scripts. So I'm going to use my execute SQL task, and I'm going to call it name, and I'm going to say create, and then whatever my table happens to be called. And then I also have to tell it what connection this lives on. And remember, we have target already set up, so we're good to go. And then the last step is we need to go ahead and tell it what SQL to actually execute. Execute SQL, like many of the things in BIML, as you play around with it, you'll notice it has a lot of options in here. I could point this in a file to go find my query. I could either a file connection or an external file by giving it a file path. I can give it a variable input, all the things that execute SQL itself can do. But I'm just going to give it direct input. I just want to give it SQL. And for that, I'm basically going to do the drop and create DDL. I'm just going to put that in as a placeholder. We'll see how we use that in just a second. And this is looking like a pretty good scaffold. I've got everything basically that I need here. Let's go ahead and now put in my tags. So I don't need to go and write that hard line of code that talks to the database anymore. I don't have to do that again because I've already got everything I need in order to generate these scripts in my in-memory table that I've already created. So now I can just go directly into this loop and say for each var table in, remember root node where we get access to everything? Root node.tables, just like there's a table tag under the root node, there's also a table property, and that's a reliable rule. Anytime you see a collection tag, you know there's going to be a property named exactly the same thing. So for each of those tables, I want to create a package. And I want to create an execute SQL task. And remember, we also here have to close out this tag. So here's my execute SQL, and I don't want to have them all named create table. I want to give them custom names. So I'm going to call them create table.name. And the Other thing that I want to do here is create do the drop and create DDL. So we actually have a convenient API method that does that. On table, you can call, and this is something where you definitely want to check the documentation or use one of the editors that has IntelliSense for the C# bits, because it'll give you all the different things you can do. You can get lists of columns. We have a bunch of helper methods on tables and columns that allow you to much more quickly write out custom T-SQL stuff. In our case, we don't actually have much to write here. All we need to do is get our drop and create DDL, and we follow the Pascal casing rules that the .NET Framework uses. So we just get the drop and create DDL statement, and that's it. I told you things were going to start coming together quickly. We're done right now. Right now, if I go ahead and generate this, it's going to build a package that has the master table deploy that creates my target schema. So what are we waiting for? Let's do it. I'm going to go ahead and select all three of these files, and I'm going to do a build. But actually, I did forget one step. Let me back up for 1 second. I'm iterating over all of my tables here. How do I specify that deploy target tables runs after create table metadata? Because if create table metadata runs second, we're going to be iterating over an empty collection because tables haven't been created yet. One of the options is it actually builds things in the order that you click them. But instead of having to get that right all the time, what you can do is you can force things to run in certain orders by introducing a directive at the top. You just put template and you say tier equals. By default, anything without a Biml script tag in it, without a code nugget, is in tier 0. So environment qualifier, remember we didn't have any code nuggets in there. Create table metadata did have a code nugget. By default, that's in tier 1. I specifically want deploy target tables to run after create table metadata, so I put it in tier 2. And there we go. Now it doesn't matter which order I select them in. I can just go ahead and do my multi-select, and I can do generate SSIS packages. Now I also could have done check Biml for errors, and it would have actually brought this up for me. It said, wait a second, then column 20. So if I go ahead and jump over to my file here and look at, sorry, it's over here, line line 5, we'll see that I actually made a mistake. So trust your errors here. It says source does not exist in the current context. That's what my error said. Why is that? Because I don't actually have anything defined in source. I have something defined in source connection. So I can go ahead and fix that. And this is one of the things that with Biml early on, it can be a little nerve-wracking sometimes, but trust those errors. And read them literally, and they will tell you what's wrong in most cases. One other thing it says is it doesn't contain a tables definition. And just for the last error that we have here, it actually is called table nodes. And once we have done that, we should be able to do a build and get everything clean. So you guys can, at your own desk, decide whether that was intentional or whether intentional to show you the error handling or whether I made actual mistakes. So here we have master table deploy.dtsx, and when I open it up, there we go. Here are all of our staging scripts, and they run in parallel. If I wanted them to run one right after the other, I could introduce precedence constraints, and it's got our drop and create DDL for everything that we need to do to create these tables based on my Scratch database. So if I switch over here to SSMS, we'll see that I've already created data pattern stage as a database, and I've already created the staging schema. Now, I could have done this automatically through the scripts as well, but it's just as easy since normally Ops wants to manage the creation of those things anyway. And I do have a bunch of tables already in here. So what I'm going to do is actually just go ahead and delete this. And I'm going to create a new database so that we're actually doing everything entirely from scratch. So we're proving that we don't have anything funky going on. So we've got data pattern stage, and I'm going to go in here to schemas, and I'm going to create a new schema called STG. And with that, I've now got my completely empty database, and I can, no man behind the curtain, hit run, and oh, by the way, when you see errors in the list, this because it doesn't understand the Biml files. One other thing that you want to do here, it says a different protection level in the project. This is something that you'll often get with your packages. You can actually define your protection level in your package that's being created. The other option is you can, of course, change it in the project. One of the best practices that I personally follow is to have all sensitive information done through configuration. So I always change it to do not save sensitive data and do all my sensitive stuff in configuration. So now that I've done that, I can do my run. And there we go. It's created all of my schema information, and I can update my tables. And there we have my tables. So now that we've got our tables, let's put some data in them. Let's have some fun with that. So I'm going to go ahead and switch over and create a whole new automation package, a whole new set of automation. Now, instead of just automating my target tables, I want to automate my load packages. So here I'm going to call this one create load packages. And just like before with target tables, we're just going to go ahead and scaffold this out. And I'm going to create packages. Oops, I did package projects by mistake. I actually just want to have packages. And then inside packages, I want to have a package. I'm going to name the thing equal to whatever, copy table name. Just put that as a placeholder in there. Excuse me. And then just like before, I want to go ahead and have a constraint mode of a parallel. And then in here, I'm going to have some tasks. And here, my tasks are going to be a little more interesting. In this case, I actually want to have a data flow. And my data flow name is going to be equal to, I can just call it copy table. I can call it whatever I like. And inside my data flow, I need to have some components. We actually have a slightly different name for it. We don't call them components, we call them transformations. That's a historical thing. It probably should be the components tag instead of the transformations tag. But c'est la vie, that's what it is. Now, inside our transformations, we're going to need to have an OLEDB source because we're going to be loading data out of our source. And our OLEDB source is going to have a name. And remember, I'm kind of just doing this quickly so we can get through stuff. But if I were doing this for the first time, I would probably close the tag out and look for the blue squiggles and fill everything in based on the editor helping me. And then I'm also going to have a connection name of source because I'm actually pulling this out of the source system. And just like before, I can point it at tables, or I can get table from variable input or variable input. In my case, I'm just going to do direct input, just like we did with the last execute SQL. In here, I want to have a select statement. Well, I might do select star from, we'll fix that in a second, don't worry. I heard some people cringe over the line, even with the mute on. Select star from, we need to get the name of our source table. Well, what we're actually going to want to do there, and I'm not putting the tag in yet, remember how we had that source schema qualified name tag that we put in the annotation? This is where we use that, right? So we're going to be able to go and get that back. And then the next thing we do is we just load it into a destination. And the destination name here is equal to load rows, or whatever we want to make it. You can name this thing however you want to, and that's the beauty of Biml. It's not prescriptive. You can do really whatever makes sense for you and your business problem. And then in here, we're going to have a table output. And then the table output is we're just going to reference that table that we're actually loading up here. And we'll show you how to do that in code in just a second. And that's really it for the scaffold. One of the things you're going to notice here is that we're not specifying data flow paths. I can actually say, here's my input path, and it's going to point at this output path, and I can hardwire all my stuff. But by default, for things that have a default output path and have a single input path, we'll automatically wire those up for you, just based on the order that they appear. And furthermore, you never have to specify metadata to say, here are all the columns in the path or anything like that. We'll automatically do that for you unless you want to override. There's actually a columns connection under import path where you can go ahead and customize things if you want to. But in general, we prize convention over configuration. If you don't need to configure it, don't configure it. We'll take care of it for you. Okay, so now the only thing we need to do is go ahead and put in a for each in here and start to have fun with it. So we're going to have a for each var table in root node.tables and do our open brace. And we're going to be iterating over this here to create a bunch of packages. So I put my end tag at the end of package. And once I've got that done, I need to go ahead and customize the name of this guy. So I'm actually going to call this copy table.name. And if I wanted to uniqueify this further, I could do schema qualified name and stuff. And even if schema qualified names contains illegal characters for SSIS names, we patch that up for you. We change those into underscores. So we've got table.name. Actually, we can even go a little further here if we want to, just to show you some of the options. You can set like data patterns, underscore, table.schema. dot name, and then underscore table dot name. Basically, name it whatever you like. And then the only other things we need to do is jump in here and actually fill stuff out. So I can say this is equal to table dot. Now we had this annotation tag. How do we get that out? You have a helper for that called get tag. So I say get the tag with the tag of source schema qualified name, and that's it. That's all I need to do to get that bit of metadata that I stored back out. And then in here in the table, I'm going to say, well, I want to take the table and I want to do name. But I don't want to just do name because there could be multiple tables named the same thing. I actually want to uniquely identify this name, this thing. Anytime we have a named object, scope name always gives you the absolutely, completely unique name with all the scope qualifiers. So that'll be database.schema.name, and that'll just spit that out for us, so we'll never have any ambiguity in there. And that's actually it. This will build at this point. But I do want to address this select star. I mentioned all of the different helper methods that we had around tables and making it easier to do SQL stuff with them. Well, one of them is table.get column list. And this will actually give us a comma-separated list of all of our columns with bracketing. And we can actually, there are actually overrides for this that will let me filter out certain columns based on a variety of criteria, or that will let me change what I use as my delimiters, or apply table aliasing if I want to. All that's there, but for our purposes, we really just need this this standard list. So given this, we're actually all set. So now I can go ahead and do my build. Well, I don't need to build master table deploy again. I only really need to build my load packages. So I'm just going to multi-select my environment, my create table metadata, and my create load packages. But just before I do that, I'm going to play the same trick that I did earlier, because I want to make sure that my tables are already in memory. So I'm going to set this to tier equals 2, just so I don't have to pay attention to what order I click things. And with that, let's see if I have any errors. No errors. It's actually going ahead and querying against the database, and there we go. Here are all of our packages that copy out every single one of those tables. And I can open them up, and I can run them. Just doing a quick little build and save here. And there we go. And this particular table didn't have any rows in it because it's a Scratch database, but certainly the worked. So looking at this, there are all sorts of directions we could go from here. We could create a master load package that called each of these individual packages. We could do a variety of other things. One of the things we are going to do, what we could do also is say, you know what, I don't want to have a separate package for each of these. I just want to have one package. It's this deal with a whole bunch of packages. Well, one of the things I can do here is I can just cut this tag. So here's how fast I can refactor. And this is, if you haven't had a wow moment yet, this might be a wow moment for you. I can go ahead and cut that out, and I can just move it right in here. Cut, move, and instead of having my copy data patterns in here, I'm just going to say this is copy data, because now that's outside the loop, so I can't refer to those variables anymore. And then I instead want to have the custom name on the data flow. And just that easy. Watch this. This is insanity how fast it is to refactor stuff with Vimeo. I'm going to delete all those packages just so they're out of our way, and now I'm going to go ahead and do a rebuild. Watch this. Oop, I made a little mistake here. Template 2, data flow. Oh, I left a bracket in there. And let me make sure that I put my bracket back. There we go. Let me go ahead and do a build. Those are the risks of a live typing demo, everybody. And there we go. Copy data is already done. And now that fast, I said, instead of having 100 packages or however many packages, it's actually arbitrary depending on my data source. Now I've got it all in one big package. And from here I can further customize. But looking at this, we still got a few minutes left. I'm going to go through and make one modification. Because you might have looked at this and said, you know what, that was great. But Scott, you said the staging environment to have these other features. What you did so far, I mean, that's table import wizard. Impressed me. So if you're not impressed, let's go ahead and start doing something just slightly more interesting. So what we did was we took the columns directly from the source instead of adding in, let's say, metadata columns or putting in data scrubbing logic. So what would it look like if we wanted to, let's say, do some data scrubbing logic? Well, instead of just spitting out the columns directly, watch what I can do instead. I can say for each var column in table. So notice now I'm jumping back to the original create table metadata, and I'm going to make it a little more interesting. So I'm going to say table.columns, and what I'm going to do here in the table is I'm going to say instead of just doing table.columns.getBiml, I'm going to do something conditional. I'm going to say, you know what? This data source has a whole bunch of ANSI characters in it, ANSI strings in it, and I don't want that. What I want instead is to convert all those to Unicode. So for most columns that aren't strings, I'm just going to be able to do column.getBiml. But for columns that have ANSI strings, I'm going to want to instead actually define my column and give it a name that matches the original column, column.name, and that the data type, now because it was an ANSI string coming in, I want to make it a Unicode string. If it was ANSI, we would actually put ANSI up here. So I'm going to have a Unicode string, and then the only other bit of metadata that I need to correct for is the length. So I need to say I actually want my column .length to be the length that I use here. So now the only thing I need to do to make this work is put in my logic to decide when I do one versus the other. So for that, all I do is say if column.datatype. Now, almost all of our data types throughout the entire system, and I'll just be explicit about it here so you can see the whole thing, even though I could just do DB type directly. It's system.data.db type. We standardize on DB type almost everywhere. If my data type is an ANSI string, then what I want to do is do this correction thing. Otherwise, I want to just spit out the column as was. And that's all I need to do. And now once I've done that, I can actually go ahead and rebuild my my target tables. And it's going to say, hey, do you want to overwrite master table deploy? And I say, absolutely, yes, I do. And now my master table deploy is not going to be terribly interesting to look at just yet, but I'm going to go ahead and deploy it because we're going to need to use this a little later. Now, I have, at this point, my source system has all these ANSI strings. My target system has all these Unicode strings. If I now open up this package that I created before, I'm going to get some complaints telling me that, let me close this and reopen it so it rechecks the metadata. I'm going to get some complaints telling me that it's broken. Wait a second, I can't convert from ANSI to Unicode. What are you talking about? So what I'm going to do is I'll jump into my load packages, and in here, I'm going to put in the code that matches it on the other side. So I'm going to say for each var column in table.columns.where. Now, where is this thing called link? If you haven't heard of link before, I'm just going to whet your appetite with it. Link is something that allows you to define these little inline functions that that you can use to like filter collections and stuff. It's a SQL-like query language that's built on top of the .NET Object Model and in other providers as well. I'm going to point you to some great link samples that can get you up to speed on. And you don't need to use link in order to do this. I could do it without link, but with link this becomes really easy. I just say where my column dot data type is equal to system.data.dbtype .ANSI string. So it's saying, hey, go ahead and only give me those columns that have a data type of ANSI string. And once I have those, what I want to do, and you guys can probably guess what I'm going to do next, right? I am going to create a data conversion component. And that data conversion component is going to just be called, column.name. And I'm going to say convert in front of this. And the next thing inside there is I need to actually tell it which columns I'm going to be converting, and I need to close out this tag as well. So data conversion, and the switching around to the lines is just the IntelliSense trying to help me. In a lot of cases, you're actually better turning off the IntelliSense once you start having these tags in here. And then the only thing I need to do here is say I want to have a column, I want to have a source column, I want to have a target column, I want to have a data type, and I want to have a length. And I know my data type is going to be string. I know that my source column is going to be column name, and we're in the home stretch here, and my target column is going to be column name, and I know that my length is going to be column.length. And just like that, I've just added a data scrubbing rule, and the sky's the limit from here. I can keep adding additional logic, whatever I want to, and the best part is it's entirely reusable. So Now, I can even have annotations at the root level to say, hey, do data conversion on this table only if it has this annotation on it, right? So you can start to have metadata that's living in a database someplace that drives your entire ETL process end to end. So let's go ahead and build this and watch what happens. It says, hey, copy data is being overwritten. I say, go for it, because we've now fixed it. And there we go. We have, did I not get this right? Didn't actually do a rebuild there. For each column in table.columns where, I see the issue there. I actually made a slight mistake. I forgot to put my my annotation here on the create table metadata. So in addition to changing the column, remember that I also need to pass along the fact that I did something. And this is where my annotations come in. Annotations. Because remember, we already changed it to string, so it was never firing on ANSI string. Annotate type is equal to tag, and then my tag here is actually going to be equal to convert to Unicode. I could call it anything I wanted to, and then in here I'm just going to say yes. Right? This is my own format, effectively, my own micro format that I'm defining in here. And then I just need to close out my column. So now that I've done that, I just hop back over here and make one quick change to my create load packages, where I say I can, instead of checking this, I'm just going to say where c.get tag convert to Unicode is equal to yes. And that's actually going to accomplish the same thing for me here. And now I do my rebuild. Copy data, and there we go, no X's. And in point of fact, when I open it up, there are all my data conversions. And you might say, hey, Scott, why didn't you put it in one data conversion? We're running a little short on time, so I'm not going to do that. But it's pretty easy. You can imagine, just like I moved the for each loop before, to do a very similar thing here where I move the for each again and pop things in the right place so that I'm doing it on the columns instead of on the instead of at the data conversion level. So now that I've done this, I can actually now go ahead and retarget this at whatever I want to. So I have this script that works. I can run these. I can run this large copy data package here. Let me go ahead and just run this one so that we don't spend time waiting for SSIS to run, and we'll see that it runs successfully. But let's say now that I want to do AdventureWorks or something else. All I need to do now is hop into environment. And this is the best, really the best part, right? I just changed this one thing, from data patterns to AdventureWorks 2012. And just like that, I can go in now and first create my target tables. That's step one. And AdventureWorks is a little bigger. It's talking to the database right now using the import. We can see that SQL Server's doing its thing. And as soon as it finishes, I'm going to get my box up saying, do I want to commit? And I say, yes, I do. Thank you very much. It says it's got an external update. I go ahead and do a run. And given the time, I'm going to go ahead and stop here, but you can see how that goes from here. You go ahead and run it and do the next thing. One other quick note, there's a naming convention that works really well on these, where let's say you have a two-step process like we do, where first you have to deploy the target tables, then create the packages. Use this format where you can do, where you have each step as a number, and you have either the number in the step, or you have an X if you don't need to run it. So we need to run in environment, whether we're building the target tables or the create load packages. The same thing with the in-memory table metadata, but the deploy target tables we only need to do on the first step. So I do 1-X, and the create load packages I only need to do on the second step. So when I'm actually deploying these things, if I am on step 1, I just highlight everything that has a 1. If I'm on step 2, I just highlight everything that has a 2. And you can go arbitrarily high. You can do 3, 4, 5, however many steps you need in order to build out your entire end-to-end solution. I think that's it. That's what we have time for. I went through and did all of this live. Even with a couple little mistakes here, like the get tag, you can see just how quickly this stuff is to do, and you can start to see the potential of just how much you can add. We did some data scrubbing stuff. We talked about adding in metadata columns to actually change what's being pulled down from the source. And whatever you want to specify, it's just a question of writing the scripts. And if you have something that can be patternized, Biml is your patterns engine that lets you create those patterns and reuse them in a way that, as you can see, is much more flexible than something like SSIS templates, which you instantiate once and then you're kind of stuck with it. You don't have that rebuild capability that you have with Biml. And you certainly don't have the capability to go off and inspect metadata sources and whatnot. So I'm going to go ahead and switch back over here to the slides and just put up a resource slide that you guys can look at. This is going to be available online as well. If you want to learn more about Biml, go ahead and follow @BimlScript on Twitter. We only talk about all the free stuff on @BimlScript. We have a LinkedIn group called the Biml Users Group, where you can ask questions and get to know other Biml users around the world. We also have a great site called BimlScript.com. I don't want to spend too much time there, but we actually have some walkthrough tutorials. The site kind of stands on its own. If you click on Get Started, we've got your first walkthroughs. We tell you all about downloading and installation. And then once you've been through your first walkthroughs, you have the opportunity to go and look at some snippets and walkthroughs that other community members, again, from around the world have shared. And this often will give you a nice starting place where you can go ahead and look at some snippets that are available, find one that's close to what you're trying to do, and then go ahead and run with it. So I'm going to go ahead and put that this resources slide back up. I know I didn't leave a ton of time for questions, and I'm not sure exactly how that goes, but if anyone has questions, let's go ahead and pull them up here. Okay, there we go. So yes, the SSIS package is completely updated. And that means that if you add a column, if I had more time, I would have actually gone to the source system and added in a column and altered one of the columns and done a rebuild, and you would actually see how the metadata breaks and then gets fixed. You can do project variables in BimlScript, absolutely. You can do, so project parameters can be defined. That's what the package project thing is for. So just create a package project and put parameters underneath that, and then you can reference those just as you normally would from expressions. And I believe we have some samples for that on the Biml forums. When you generate new packages, do they generate new GUIDs? The answer is maybe. If you don't specify a GUID, then absolutely they get new GUIDs, and we generate new GUIDs for you each time. However, it's also possible for you to go ahead and have a GUID library, so you can actually put in a GUID tag. Let me go ahead and just create a new file here so we get our IntelliSense on it. If I go ahead and create a package, packages, package, and then what we have here is it's called ID. So if I put ID in there, I can put any GUID I want in there. Generally, the way you would do that, if GUIDs are, if it's a very important scenario for your GUIDs to always match, what you can do is have a little database table someplace where you actually store your GUIDs for packages for certain tables, and that becomes part of your metadata. In general, what we found with folks, though, is that once they start using Biml, they stop thinking as the package as being the thing that they source control, and they start thinking of the Biml as being the thing that they source control. And the packages are almost like build targets, like if you were running the C# compiler and getting a binary out, you don't really source control your binaries. Same idea here. This will work in all versions of Visual Studio that support SSDT or bits. So it works in 2005, 2008, 2010, 2012, and in 2013 as well. As long as in 2012 and 2013 you have the additions to support the SSDT project model. You can create tables based on queries and stored procedures. We have some default ones that we generate for you. But if you want, you can go ahead and just basically write custom scripts to do whatever crazy stuff you would normally be doing in T-SQL by hand. You can actually auto-generate those off of the object model. And we found that a combination of this sort of markup and object model interacting together is actually really powerful. You can even write your own methods that you're able to call from elsewhere if you like and use it. So there is a way to reverse engineer BimlScript. I don't want to talk about any proprietary stuff. There is a free trial of the product called Mist that you can use to reverse engineer existing packages and existing assets, and also it has visual designers where you can create templates drag and drop. It's actually a designer that's a little nicer, and I think a lot of the people's opinions than what's in BIDS or SSDT. But that's a proprietary product. There is a free trial, but eventually you would have to pay some money for that. So that is a caveat there. You can use OLEDB. You can use OLEDB or ODBC. I just use OLEDB because, well, that's what I have the sample in already. ODBC is fully supported. And generate BIML files from existing packet project. I just mentioned the solution for that. There is also going to be a web service in the near future that allows you to do that as well. But for now, it's just in that paid tool with the free trial.
Okay, excellent. Thank you so much, Scott. We've got a lot of thank yous from the attendees as well here. That was a really good presentation, and I think everyone who attends is probably agreeing with this as well. So thank you so much. And the presentation will be, or the session recording will be available from the presentation archive tab in bi.sqlpass.org. Now, I think there's a question about making this solution that you've just created available for the attendees. Is that going to be possible?
Yeah, absolutely. So I'll go ahead and put all this code on bimlscript.com later this evening, and maybe, Julie, we can send out a reminder mail to everybody with that location once it's up.
Yeah, that sounds good. And I can just link it on the presentation archive area as well. If you give me the link, that shouldn't be a problem at all. Excellent. Thank you so much, everyone. Thank you very much, Scott, for presenting today, and I'll see you next time.
Thanks, everybody.